Should we get started?
Yeah, okay, so today we have the privilege of hearing about exploring the predictive power of the Numeracy Screener around the world. The symposium is chaired by my good friend and colleague, Stephanie Bugden, who's currently a postdoc at the University of Pennsylvania. So we'll hand over to her.
Awesome, thank you. And welcome everyone for coming. Good morning, good afternoon, and good evening, I guess. So our symposium, I think, is set up a little bit differently than most. Today I'm going to provide a general introduction on behalf of all of our speakers to avoid reviewing the same papers and the same concepts 4 times. And our hope is that that could shorten our individual talks and increase discussion time at the end. So I'm just going to get started. So thank you, Rebecca. Our symposium is titled Exploring the Predictive Power of the Numeracy Screener Around the World. And as I think everybody in the audience knows, numerical magnitude processing, which is the ability to understand that numerical symbols represent a total number of items in a set, or the ability to discriminate between multiple sets of objects, is an important foundation for mathematical development. And as part of Nadia's dissertation with Daniel Ansari, she developed the new Numeracy Screener, which is a paper and pencil tool that was developed to assess symbolic and non-symbolic magnitude processing skills. So the Numeracy Screener is composed of a symbolic comparison task and a non-symbolic comparison task. And in these tasks, children are given a booklet. And you see here the first page of both the symbolic and non-symbolic comparison conditions. But children are asked to cross out either the numerically larger number or the larger dot array as quickly and accurately as they can. Children are given either 1 or 2 minutes, depending on their age, to complete each of the conditions of the assessment. And it can be administered individually or in group settings. So as a former teacher, it was Nadia's goal to develop an assessment tool that was easy to administer across different educational contexts, cultures, and that could be easily scored by teachers or researchers without using any sort of technology. So in the first step to evaluate its effectiveness, Nadia investigated whether the performance on the Numeracy Screener correlated with individual differences in standardized tests of arithmetic achievement. And so she found that performance on the Numeracy Screener across both symbolic and non-symbolic conditions were correlated with a speeded arithmetic fluency test, or the math fluency subtest from the Woodcock-Johnson, as well as a non-speeded assessment of calculation skills, so the math calculation subtest from the Woodcock-Johnson. And this was in elementary school children, so specifically 1st through 3rd grade children who scored higher on the math fluency subtest as well as the calculation subtest, also obtained higher scores on the symbolic and non-symbolic conditions of the Numeracy Screener. They additionally found that the symbolic comparison was a unique predictor of both math fluency and calculation skills. So in a multiple regression model that included age, measures of IQ, and working memory, only the symbolic condition, but not the non-symbolic condition, was a significant correlate of math fluency performance. So these findings suggest that symbolic magnitude skills are a critical and more important foundation for developing basic arithmetic skills. In a follow-up study, Zach Hawes explored whether the Numeracy Screener assessed any younger sample of children, and this is specifically 5- and 6-year-old children who are in kindergarten in Canada, was associated with teacher-assigned math grades 1 year later. And what they found was that both conditions, again, in this time were correlated with teacher-assigned math grades. So on the x-axis, you have the total number of items correct on both the symbolic on the left and the non-symbolic conditions on the right, and teacher grades for mathematics on the y-axis. And extending the results from Nadia's paper, they also found that the symbolic comparison is a strong and unique correlate of first grade teacher math grades. And the symbolic comparison remains significant in a regression model that included number line estimation as well as arithmetic performance. So together, these studies suggest that the numeracy screener, in particular the symbolic comparison task, shows some promise for assessing basic numeracy skills in very young children and a potential tool to identify children at risk for developing mathematical difficulties. However, the numeracy screener was developed with the intention to be used across different cultural and educational contexts. And while the studies conducted in Canada do show some promise and interesting theoretical insights, whether these patterns of results found in Canada generalized to other countries, in particular non-weird samples, remains an open question. So the goal of today's symposium is to explore the relationships between symbolic and non-symbolic magnitude processing, assessed using the numeracy screener, and math performance in Chile, Singapore, Poland, Ghana, and Cote d'Ivoire, West Africa. So I'm going to turn it over to Joanne. She's our next speaker. But just note that I've asked the speakers to include some analyses that showed performance and accuracy on the symbolic and non-symbolic conditions of the numeracy screener, as well as some correlation analyses and a multiple regression, only including those conditions before adding any of their specific control variables to try to keep some consistency in our analyses, and hopefully we can make some loose observations about the patterns of results that we see across the different samples of data that we are presenting today. And our hope is that our symposium can sort of spark some interesting discussion about the role of culture in math cognition. So I guess I will stop share for Joanne.
Does that look okay for everybody?
Yeah.
Yes.
Okay, good. So thanks very much, Stephanie. My name is Joanne LeFevre, and I'm going to talk about data from Chile, although as probably most of you know, I'm actually from Canada. This project that I'm talking about was actually conducted by Mene Sasparage in Chile, and this was a picture of Santiago, which is a very large and crowded city. In terms of the analyses that we're working on a paper as well, the analyses are done in collaboration with my wonderful group of colleagues. The project that I'll talk about, that the numeracy screener was included in, was a 2-year longitudinal project, and it included 419 children in total over their 2 years of kindergarten. So similar to the children in Ontario, in Chile, children go to kindergarten for 2 years before they start grade 1. The numeracy screener, children in this project were tested 3 times, beginning of kindergarten 1, end of kindergarten 1, and end of kindergarten 2, but the numeracy screener was given twice, end of kindergarten 1 and end of kindergarten 2, which gives us the opportunity to look at what happens over time. And just a little bit of context about Chile, it's a prosperous Latin American country. All the children in this project were Spanish speaking, it's their first language and their only language. And in comparing the children's experiences in Chile to those in Canada, even though they are similar in that both groups go to kindergarten in grade 1, in Chile, kindergarten is relatively more formal than it is in Canada. So it is really considered more like school. The kindergartens are in fact in schools, and children more typically start at 4 and continue through up to grade 6, I think. Importantly, Chile, even though it is a relatively prosperous country, has a lot of socioeconomic diversity. And the schools are segregated by socioeconomic status. So although I'm not going to talk about it a lot today, I will present a little bit of data breaking the schools down into 3 groups according to their SES. All of the schools in this study, the children are private schools, but the ones in the low and the medium SES communities receive government grants. The best way to think about it is that in, for example, in the low SES schools, the parents tend to have less education, their incomes are lower, and the neighborhoods are poorer overall. So the first question is, and I tried to stick to Stephanie's suggestions, do we replicate the patterns found by Hawes et al. With Chilean children? The samples are very similar, the ages are very similar, the size of the groups are very similar, so it's an interesting question. First of all, in terms of the correlations, this shows the similar correlation as in the Nosworthy et al. Study. The performance on the Numeracy Screener is on the y-axis, arithmetic is on the x-axis, and you can see that for both the dot and the digit version of the screener, there's a correlation between arithmetic performance and screener performance. So that's good, it replicates. We also found that performance is better on dots than on digits, and that was also found by Hawes et al. The dots versus digits is on the x-axis here, and you can see that even though both groups do show a difference where dots are, the performance is better on dots than on digits, the difference is much larger for the younger children. They're much larger when the children are younger, because this is a repeated measures design, and this is a 2-way interaction. So not only do they get better overall, but the difference between dots and digits gets a lot smaller, although it's still significant. And furthermore, I wanted to show these data about SES, although I'm going off the script a little bit here. You can see that the difference between dots and digits is much larger for the low SES group than it is for the other 2. They don't differ from each other either in overall levels of performance or in the size of the difference between dots and digits. It's really the low SES children who are really carrying this effect. In terms of do dots and digits predict unique variance in arithmetic, what I thought I would do is show it a little graphically. The whole circle here represents all the variability in arithmetic, and I did include some control variables, although it doesn't change the pattern at all. So the pattern looks exactly the same. Essentially what happens in this multiple regression is that digits contribute unique variance, which is exactly what Hawes et al. Found and Stephanie reported. So that's the blue slice of pie. However, I also wanted to point out the nice thing about regression is you can also look at shared variance, which is also relevant to understanding what's going on. The gray slice of the pie is the shared variance between the digit and dot comparison, and it's actually larger than the unique variance associated with the digits. Okay, I'll come back to this. So in summary, yes, we replicated Hawes et al. In late kindergarten, digit comparison predicts unique variance in arithmetic, so the digits are happy, but dot comparison does not predict unique variance. The dots are sad. Okay, but I wanted to touch a little bit on why number comparison might be something important. I'm sure many of you are familiar with a paper by Van Binst et al. Where they said that number comparison is as important to arithmetic as phonological awareness is to reading. And that's a very strong statement about the underlying processes that might be going on with number comparison and how they might be relevant to understand children's numeracy development. And that raises the question of what the numeracy screener actually measures. I mean, we know it measures comparisons, but what is that supposed to tell us about kids' processing? In Hawes et al., they said that the numeracy screener measures young children's basic magnitude processing. And so then I thought, well, why does digit comparison predict unique variance compared to dot comparison? What do we actually think about that? Why is that important? And I think it's something, probably something about both kinds of comparisons tap into children's magnitude knowledge. And the digit comparison in addition taps into their symbol processing knowledge. So if that's true, then that additional unique variance that the digit comparison accounts for is presumably because of children's developing symbol knowledge. And that's supported by the pattern where the difference gets smaller for dots versus digits. And it also suggests that the same pattern should hold for any numerical tasks that require symbols because the digit part is picking up on their symbolic knowledge. Just reminding you again, this is the same picture that you already saw before. This is for simple arithmetic. This is the pattern. Dot digits predict unique variance, but there's lots of shared variance. We could maybe look at digits as the symbol part and the shared as the magnitude part. Okay, one of the other tasks we had was a number naming task where children are just shown a number and they have to name it. That's sometimes called transcoding. And the assumption is that no magnitude information is actually needed. It's not directly referenced. You don't have to use it. And in fact, the digit portion accounts for somewhat more variance here than it did in arithmetic, which suggests it's consistent with the idea that the digit is accounting for symbol processing. But note that the shared variance is still substantial. There's still lots of shared variance going on here. Presumably that's not accounting for magnitude processing in number naming, but maybe it is, I don't know. So then I thought, well, I'm gonna push this even farther, push this model a little bit harder and look at receptive vocabulary. And in fact, the pattern looks very similar with receptive vocabulary. There's unique variance associated with digit processing. There's shared variance associated with both digit and dot processing. And you can see the little skinny orange line in there, which we didn't even see in any of the other graphs. There is starting to be a little bit of unique contribution from the dots, although it's not. It's marginally significant here. It's a very small portion, about 2%. So what is that? Receptive vocabulary, this is the PPVT. It's not about symbol processing. It's not about magnitude processing. What's going on? Just to sort of summarize and push the point home, the patterns all look very similar across these three. I did cheat here, and sorry about this, Stephanie. I did control for age and gender and SES and a working memory composite, but it doesn't actually make any difference to the pattern. The pattern looks exactly the same whether you control for anything or not. So in conclusion, happily, the numeracy screener shows very similar patterns for Chilean as Canadian children, but I think some of the other patterns in the data that we have suggest that we need to understand what digit comparison is actually measuring. So why is it a measure that we should be interested in? And push a little bit harder on, does it specifically screen for numeracy weaknesses, or does it say something more about the development of children's knowledge in school-based kinds of tasks? So thank you.
Joanne, do you want to answer maybe Andrew's question and then we can move on? I don't know if you saw in the chat. So Andrew asked,
I'm
did you
happy to
test?
ask it out loud too.
Oh, okay, there we go.
Yeah, so I was really interested by your the interaction graph that you had there with the SES by difference in non-symbolic and symbolic number comparison. And so I just wanted to know if you tested for whether you found any SES differences for children on their non-symbolic number comparison. I didn't take a look to see if those error bars were significantly different. And if not, how do you think this plays into the idea of non-symbolic number being kind of more evolutionarily preserved or innate than symbolic number skills?
Andrew, if I understand your question correctly, the overall differences were there for both dot and digit comparison.
Okay,
great. The low SES kids always were worse, and they always showed bigger differences between them. So I didn't show that the three-way interaction is not significant because the pattern is exactly the same. I would say that the trend is that for the middle and high SES kids, the difference between dot and digit comparison gets very small, and depending on what statistics you use may or may not be significant, but it's still significant for the low SES kids even at the end of the second year of kindergarten.
Great, thank you so much.
I forget the word.
Okay, yeah, I see the question. We use exactly the same measure that Stephanie described. It was all visual input.
Okay, so let's move on to our next speaker. which I already forget the order. Is it Dr. Chen?
Okay, so
Singapore?
I'm going to, yeah, so I'm first to share my screen. Okay, so I'm going to present the data from Singapore. Firstly, I'd like to share some background about this study. In 2017, actually, Singapore government announced an initiative in early childhood education. So the Ministry of Education spent a lot of money to set up a new research center on child development. And this center focusing on early years of children. Also, this center is interested in international measurements and also early interventions. So that's why we are doing some research on Daniel's numeracy screener in Singapore. For this study, we recruited in total 216 4 to 5 years old preschoolers in Singapore. I think this age group should be the youngest cohort for this numeracy screener. And also, this participant represent the whole races in Singapore. We got the most of Chinese, and followed by India and then Malay. We went to 3 childcare centers and 6 preschools for this recruitment. For this study, we used the numeracy screener, the kindergarten version. So we asked the children to finish the symbolic section for 2 minutes and another 2 minutes for the non-symbolic one. After the screener, each children completed the wild math fluency test. So they spent 1 minute for addition and another minute for subtraction. The procedures are quite straightforward. So we went to the school and the center, and we tested each child individually, and also each child was tested twice. We're 2 weeks apart. We calculated the adjusted score for final analysis. Also, based on some criteria, we excluded some participants from our analysis. So finally, we have 178 participants, where we have 89 girls, so half boys and half girls. Based on the table, you can say the mean score for symbolic knowledge is around 27 out of 56. And the non-symbolic one is around 32 out of 56. And so we can see the children perform much better on the non-symbolic one than compared to the symbolic one, which I think replicates the results from Joe and the Canada data. And before this study, actually, Daniel and I have had a little bit concern about the screener in Singapore, because we know Singapore kids are very good at math, so we're kind of afraid to get setting effect. But luckily, based on the means, you can say this screener actually works very well in Singapore. In terms of the reliability, from this data you can say the reliability of the symbolic knowledge is 0.8. And for the non-symbolic one, the reliability is around 0.7. And next, we control the factor about age and gender. So we got the age effect on both symbolic and non-symbolic. However, we didn't get any gender effect. Also, we found the symbolic knowledge and non-symbolic knowledge, they both correlated with children's math performance. But based on the linear regression, the result is very interesting, because we found the non-symbolic can also predict children's math achievement. So for the Singapore data, actually, both types of knowledge predict the children's math achievement. So to summarize the results from Singapore, firstly, the screener is reliable. And also, secondly, the screener is sensitive to individual differences, although we didn't get any gender differences. Finally, we can claim that the screener in Singapore, the symbolic and the non-symbolic knowledge can both predict children's math achievement. I think so. This is from Singapore. Thank you.
We have time for one question if anyone has a question. Shall we move on?
I'm trying to get my screen working. Can you see it? Yeah.
Yes.
Okay, so hi everyone. I want to share some very, very early data from Poland. So I must admit, and at the very beginning, and also apologize that these analyses are like way, way less advanced than what you have seen before, but I hope you still can see some potentially interesting results. So we did a Polish validation study of Numeracy Screener. We registered this study, this data collection. You can find the link here, and also the slides are shared on OSF. I tweeted the link to them. We were testing children in 3 different cities in Poland. So in capital, in Warsaw, then in Krakow, and in Lublin. It was, to be honest, just for, let's say, convenience reasons, where I could find some collaborators who luckily agreed to get into this project. So we collected data in these three cities, and the goal sample size was to have like 450 children altogether and 150 for the retest. Seems that we reached this goal, and we're mostly interested in age 5 to 6, but then also 6 to 7 would be like potentially interesting. And our goal and our idea was just to build percentile and standard norms for this instrument for Polish children. So what we did, we measured several background variables from teachers and parents, such as SAS and stuff like that. And then we had also 2 testing sessions with a child. So for most of the children, we had 1 session only where we measured number naming. Then we administered numeracy screener with 2 minutes per part, and then we did letter naming, number line estimation with numbers 1 to 9, and then arithmetic. It was 5 single-digit additions and 5 single-digit subtractions. And then we also used validated Polish instrument to measure the vocabulary. And in the second session, we administered numeracy screener again. And then we also had a test of critical thinking, which is like currently under development by colleagues from Krakow. And this was also kind of considered as a measure for discriminant validity, but also it was just part of validation study of this specific instrument. Yeah, and then like several things happened on the way. So probably some of you noticed that there was COVID-19 in between, and we have not finished the data collection. And now, unfortunately, we are in this uncomfortable situation that some of the data is not yet digitized due to lack of access to offices and like chaos in general, so to say. We are trying to get it as fast as possible and to have it like all together, and then coming to the results. As I say, it's very, very preliminary, and it's not based on all the data we collected. So far, we actually managed to exceed the desired sample size. This analysis here is with 563 children with gender balanced. So we are above the plan as regards the sample size. But here the first surprise compared to the other countries. So here we had actually negligibly better performance actually in the symbolic part. But if you look at the numbers on the figure and also on the t-test and effect size, the difference was very, very small, and actually the value of bias factor more or less tells us that, yeah, what we knew before doing the study, we didn't change much. So it's like almost perfectly inconclusive. Hopefully when we get the rest of the data, it somehow clarifies, like the BF value just goes into like one or the other direction to be more conclusive. And then links to performance. So this is the very, very simple regression where we had arithmetic performance as a dependent variable, and we had symbolic and non-symbolic performance, like number of correctly solved items within 2 minutes in symbolic and non-symbolic test. And we can see that symbolic score was a reliable and significant predictor for arithmetic performance. As you remember, arithmetic here was this like simple additions and simple subtractions, five problems per operation. However, there was no significant effect for the non-symbolic test. And the other point I wanted just to show you some, as I already told, very preliminary results. Here are the correlations of all the measures we used. So with green, I marked the correlations of numeracy screener with other measures, which are, I would say, quite similar to values reported in other studies. But then we have the letter naming task, which is one of the most, let's say, crude discriminant validity measures. It's just that child was seeing some letters, some Latin alphabet letters, and was asked to tell which letter it is. And we can see that that letter naming actually correlated quite highly with all the other measures we employed. And then what happens if we use, again, very, very crude measure of discriminant validity. So this is the partial correlation considering the letter naming or controlling for letter naming task. And as we see, all the correlation dropped quite dramatically, especially the ones with the arithmetic score. It just drops by half, so to say. So just to conclude, so numeracy screener seems to work in general in Polish children, but as you see, the discrepancy between symbolic and non-symbolic comparison was not observed. And at the same time, I think this overall, even very preliminary pattern of results calls that we really need to look more carefully at discriminant validity, and also the task for us to properly analyze the data we actually have. And of course, this study would not be possible without my collaborators in Poland who agreed to join, to collect the data, to organize it. It was really big enterprise on each testing site. So very big credit to all of them, and thank you for your attention.
We have time for a question if anyone has any questions. Okay. Okay, that leaves me. Okay, so today I'm going to present two studies that were conducted in Ghana and Cote d'Ivoire in West Africa. And these studies were conducted in collaboration with Dr. Sharon Wolf from the Graduate School of Education at the University of Pennsylvania and Dr. Chen from University of Zurich. And much like our previous presentations, our goals were to explore whether, similar to the studies conducted in Canada, are symbolic and non-symbolic magnitude skills associated with math performance. And this is specifically in first and second grade children from Ghana and Cote d'Ivoire. And we hypothesized that, consistent with the Numeracy Screener studies in Canada, that the symbolic magnitude processing would be a stronger and unique predictor of general math performance. So just to give a very brief background, I'm first going to present the data from Ghana. Ghana is considered a low middle income country in West Africa, and about 75% of 5 to 6-year-old children are enrolled in preschool, which is the second highest enrollment rate in the sub-Saharan Africa. However, several reports from the Ministry of Education have found that the quality of education in the classroom and learning outcomes are quite low. So the government in Ghana has launched several initiatives to improve the access and quality of early childhood education. And as part of those initiatives, they've prioritized teacher training, including teacher training for kindergarten classrooms. So the data for the present study were collected in part of a large-scaled longitudinal project evaluating the effectiveness of these teacher training programs. And there's 353 first and second grade children that participated from Ghana. And as you can see, the age range varies quite a bit. Collecting age data from Ghana and as well as Cote d'Ivoire was quite difficult. But there's a lot of variability in school attendance among the children in actually both countries. So children completed the Numeracy Screener, as well as measures of literacy, numeracy, and socio-emotional and executive functioning skills. And these were administered individually within their schools. So the early grade math assessment was used to assess mathematical performance. So it's an international assessment intended to measure the core competencies for early mathematics. So it's an orally administered measure. Children completed 6 subtests that assess their numerical identification skills, ordinality, addition and subtraction, as well as word problem solving and quantity discrimination. The dependent measure here is going to be the mean percent correct within each subtest, and that was averaged across all 6 subtests. So in addition to the math assessment, as well as the numeracy screener, children completed multiple subtests that assess literacy skills. These were assessed using the early grade reading assessment, and they included subtests that measured expressive vocabulary, listening comprehension, letter sound identification, non-word decoding, and phonological awareness. Socio-emotional skills were assessed using the International Development of Early Learning assessment. And these were items that assess self-awareness, emotion identification, perspective taking, friendship, and conflict and problem solving. And they also completed tasks that assess forward digit span, dimensional card sort, and number group tasks to get an overall measure of their executive functioning skills. The dependent measures here in this case are mean percent correct across these subtests within each of these domains. So we first tested whether there was a correlation between the symbolic and non-symbolic comparison conditions of the numeracy screener and just general math performance on the early grade math assessment. And what we found was similar to the Canadian data, where there is a strong positive correlation between both the non-symbolic and some symbolic comparison skills and math performance. So the total number of items correct is along the x-axis, and mean percent correct on the early grade math assessment is on the y-axis. And in fact, what's different with this pattern of data relative to the Canadian studies is that the relationship between the non-symbolic comparison task and math performance is significantly stronger than the correlation between the symbolic comparison task and math performance. So to test the unique associations between symbolic and non-symbolic comparison, we conducted a multiple regression analysis. And what we found was that the non-symbolic condition accounted for significant unique variance, while the symbolic comparison did not. And these associations remained, or this association remained when we controlled for socio-emotional literacy and executive functioning skills. Although you can note there that the literacy and executive functions also associated with math abilities, which is not surprising. But contrary to what we expected, a non-symbolic comparison task is a significant and unique predictor of mathematical performance in the sample from Ghana. So one might speculate that non-symbolic comparison is a stronger predictor of math abilities because they score higher on the non-symbolic comparison condition relative to the symbolic comparison task. Okay. However, we found the opposite to be the case. Children perform significantly better on the symbolic comparison task relative to non-symbolic comparison. So these are violin plots of the distribution of the individual scores. And if we even remove children who could not identify all their numbers, 1 through 10, the pattern of data does not change. So just in quick summary, we found that the numeracy screener correlates with math performance. This is assessed using the early grade math assessment. So not only does the numeracy screener correlate with standardized assessments that were developed and normed in the US and Canada, but that there's strong association between performance on the screener and in an international assessment. In contrast to the data in Canada and those presented from Joanne and Krzysztof, we found that non-symbolic comparison task is a strong and unique correlative math performance. And this result was not driven by greater performance on the non-symbolic comparison task, as children scored higher on the symbolic comparison condition relative to non-symbolic. So next, we evaluated whether these findings hold if we conducted a follow-up study in Cote d'Ivoire. So we conducted a pre-registered follow-up study. We were lucky to have the opportunity to continue working with Dr. Sharon Wolf. And we tested whether the associations between symbolic and non-symbolic comparison in the same way that we see in Ghana carried forward in Cote d'Ivoire. So Cote d'Ivoire is a francophone country. It's Ghana's neighbor on the west side. But unlike Ghana, Cote d'Ivoire has a preschool enrollment. It's estimated at approximately 8% of children. So, sorry, just to repeat myself. So approximately 8% of children are enrolled in school, and this is almost exclusively in urban areas. So the enrollment rates would be much lower if we considered rural areas. And Cote d'Ivoire is the largest producer of cocoa in the world. So in rural cocoa producing communities, poverty is pretty widespread, with families surviving on about $1 to $2 a day. And it's estimated that about 1.3 million children are actually engaged in child cocoa labor. And this interferes with their schooling. So there's a lot of variability in the amount and the quality of classroom instruction time that children are getting here. So 346 children are participated in our current study. And as I mentioned before, we don't have any age data here. It's quite challenging to collect that information, but children are enrolled in second grade. So children completed 4 of the 6 subtests from the early grade math assessment. And they completed the same socio-emotional literacy and executive functioning assessments that were administered in Ghana. However, they were administered in French in this case. So similarly, we found that children obtained significantly higher scores on the symbolic comparison relative to the non-symbolic comparison task. But as you can see here, that children in Cote d'Ivoire scored lower on the numeracy screener. And this is the case across our mathematical measures. And again, children showed significant correlations between the non-symbolic and symbolic comparison tasks and the early grade math assessment. This relationship was significantly stronger with the non-symbolic condition. So the relationship between the non-symbolic comparison task and early grade math assessment was much stronger for non-symbolic relative to the symbolic. So we replicated the results from Ghana here in this case. And that was also true in the multiple regression analysis. So if we put both symbolic and non-symbolic comparison in a regression, we find that the non-symbolic comparison remains a significant predictor, while the symbolic comparison does not. And the association remains even when we control for literacy, socio-emotional learning, and executive functioning. So contrary to our original hypotheses, and unlike the numeracy screener studies that were conducted in Canada and Chile and Poland, we found that non-symbolic comparison is a stronger and a unique correlate of math performance in both Ghana and Cote d'Ivoire. Okay, relative to the symbolic condition. I think that these findings, among others in our symposium, suggest that there are different cognitive precursors or pathways for math development, and that foundational skills for math learning do not necessarily generalize across different cultures and experiences. In the present study, we found that non-symbolic magnitude skills are an important predictor of individual differences in math performance. This was over and above symbolic magnitude skills. It's unclear to me what mechanisms are driving our contrasting results, and if anyone has any ideas, please share. But one speculation for what's driving our pattern is that the amount of time using numbers, as well as how children learn and use math in the classroom across countries, could be different, or is different. And our experiences with number symbols are going to drive the way in which we use and understand them. So children in Ghana, for example, spend less than 3 hours a week on math instruction. And this number is actually thought to be an overestimate of the actual time spent doing meaningful learning. So if children are using and learning about number symbols much less, this can contribute to their either lack of flexibility in using number symbols or potentially sort of imprecise representations. Alternately, our children learn about number symbols, and how they learn, or how they're taught about number symbols could influence the way that they're used. So studies have shown that teachers in Ghana, for example, use a lot of rote learning strategies. So in the classroom, children are learning through repetition, rehearsal, and memorization, and it's teacher-centric. So higher performance on the symbolic condition could be associated with the fact that children are learning these facts, like 4 is bigger than 2, through rote learning styles, but they might not be engaging in various learning activities that facilitates this flexible usage of number symbols. So taken together, we found that the numeracy screener did show strong associations with international assessment of numerical magnitude abilities. But in our case, the non-symbolic comparison task was the stronger predictor of individual differences in Ghana and Cote d'Ivoire. And this lends support for its potential to be used practically in a classroom. But I think it also lends support for why both symbolic and non-symbolic conditions of the screener might be important for assessing individual differences in numerical magnitude knowledge. Our findings suggest that in some contexts, administering both conditions could yield higher rates in predicting children who are at risk for developing math difficulties. But I think future research is necessary to test whether the screener can be implemented in the classroom and whether monitoring their progress could improve the quality of education. So that's it, if anyone has any questions. But also just as a discussion point here, I plotted the data across our studies just to sort of draw some inferences or observations about the variation and performance across the different cultures and countries on the numeracy screener. And that's it. If anyone has any questions, ideas, thoughts, discussion points.
There was a question from Ilse.
Can I see chat while sharing? Okay, there. So all of you numeracy.
Yeah, I can read it. I can say it out loud as well. I was just wondering whether whether anybody checked the correlation between processing speed and the numeracy screener, and whether maybe that, because I can imagine it would correlate, because you have to do it within a certain time, and whether it could explain something within the link, because I think somebody used a maths measure as well, which was also timed, so maybe it could explain something. Not sure if anybody has checked it.
I haven't specifically in our data set. I don't know, Joanne, you kind of presented anything about processing speed?
We didn't have a specific measure of processing speed, but the other task that I talked about, the digit naming task, wasn't speeded. It was a trial by trial kind of thing. So I guess I would guess that it would be correlated with speeded tasks because it is a speeded task, but I don't think that's really accounting for the relationship.
We had a combination of both speeded and non-speeded math tasks. And we still get the non-symbolic link regardless of whether it's speeded or non-speeded, even if we control for sort of executive functioning, literacy, and social-emotional skills. I know it's not really within our data set, but I know that in some of Bertha Smith's work with the SIMP test, which is the symbolic version of the task, they do control for processing speed in their associations and regression models, and the link between the symbolic comparison of the SIMP test remains significant when controlling for their math outcomes. I can't remember if their math outcomes were speeded or not.
Okay.
I don't know if anyone else had anything to add to that question or response.
Yeah, well, I think it's really important actually in our tests, our data set, we don't have any dedicated speeded measures, but because we wanted to have rather like control for language to look at specific links within like domain of math, but definitely it should be like a part at some point to control for the processing speed.
I have a question, or maybe it's a comment. Krzysztof, I think you and I both made a similar point about, you call it discriminative validity. I was talking about, well, kind of does the Numeracy Screener predict everything, you know? What do you think the best way to approach that issue is? Like, how do we narrow down the specificity of the Numeracy Screener as a predictor of math outcomes?
Yeah, well, like to me, it's somehow like the lowest hanging fruit is just to have any crude measure of like language or so. Then we can just somehow control for this, that some children just develop a little bit faster and they are like more advanced, and whichever measure we use, they would just score better because they are just developing a little bit faster. So yeah, like the lowest hanging fruit would be language and also processing speed, I guess, like for sure. But then the problem is that like with increasing number of predictors, you're also making the model really complicated, and you have like, you end up with huge battery of instruments that you need to use with very large number of children to really come up with any reasonable conclusion. I guess there was a question from Andoker. Can you all see it? If I'm, okay, please.
Oh yeah, so could there be practical experiences outside the classroom that, and my guess is yes. I think that the overall children are experiencing a much different way of life that and various different usages of numbers if they use them very much, or even if they use symbolic numbers in their home life or in their workplace, that I would imagine would shape and influence how they learn and experience sort of mathematics. I don't know precisely what those are. We don't have any assessment of sort of home numeracy, any home educational experiences to be able to explore that empirically. But I think it's an important and a critical sort of aspect of why some of our relationships or some of these patterns of data are different in different countries.
I have a comment about the comparison slide that you have up there, Stephanie. One of the things that's kind of interesting about the Cote d'Ivoire, I'm not sure this is true for the Ghana group, is that the symbolic chunk, that part, is fatter, so suggesting the children are somewhat more similar, whereas the dot is more spread out, right? Whereas the opposite is true, for example, in Chile. The dot part is fatter and the symbolic part is more. And so if we're talking about relative amount of prediction here, I wonder, you know, is it something to do with what children are good at and what they're not good at in relation? I mean, maybe it's the same argument that we've all been saying, you know, that the children in Ghana and Cote d'Ivoire have more experiences with objects and quantities of objects. The kids in Canada and Chile, that isn't predicting, it's the symbolic that's predicting, because that's where the variability is. See what I'm kind of getting at there? You think that might be part of it?
Yeah, I see what you're saying. I feel like the big hump is in the Cote d'Ivoire data there at the end, right? Where there's a lot more widespread at the tails relative to the dot comparison. But the patterns seem relatively like variable in the Ghana data set, right? Like the hump is just a little bit higher in the symbolic relative to the dot. But I guess your point though is that those humps in general are much wider. Is there a lot more variability? Is that what you're?
Well, the humps show where people are, so yeah. Right. So it's a distribution. So in fact, in some sense, there's less variability. So for the Cote d'Ivoire, the symbolic, more children are more similar, more closer together, whereas the dots are more spread out. So there's more opportunity for protection.
I see. Yeah.
And I was also wondering why are in Poland and Canada, why is there a cutoff at the top?
That's just I don't like it. I mean, that's just there isn't a tail, so there's just a lot more kids that are at the top end. But I don't know why they didn't get higher, I guess.
Yeah, but isn't it like the maximum? I would say that this is the maximum here, because this is like the correct per second. Mm-hmm. And then isn't it like the absolute maximum you could get?
So it means that some children finish the whole test, essentially.
Yes.
Yeah.
They're not supposed to, right?
But then it means that somehow but it's not the case, because you have the tails in other groups. Then I don't know.
For example, the way we did it, we administered it so that when they finished, that time was recorded. So if they got to the whole end of the test, then the amount of time was recorded, which we can do if it's individual testing, but maybe if it's group testing, that's not possible.
In our data set, we excluded kids that hit ceiling because we didn't have the recorded time in the same way that you did, Joanne. And this is correct items per second. So it's divided by the total amount of time that was administered.
Oh yeah, and then there is like comment by Daniel to the question that you asked, Joanne. So like he writes that in the paper by Zach, the dependent measure was the teacher grades, which did not have a speeded component, and then he needs to check the rest. Yeah, I think it's important here that we are at least not correlating speed with speed, but I think the issue that Ilse raised was also not only about like correlating speed with speed as regards arithmetics, but how the processing speed affects the performance in Numeracy Screener as the instrument. Is that right? Or
Yeah, that's right.
I would also comment, the results from Singapore are very interesting too, because they suggest that they show that both parts of the numeracy screener predict performance for children. So Ouhao, do you have any sense of why that might be? Why is it that, because it's almost easier to understand one or the other predicting because there's a lot of shared variance. So if both predict, that means they're really distinguishing skills in the kids. Do you have any thoughts about that?
I think probably because in Asia it's quite different from maybe the Western countries. So in Singapore or in other Asian countries, the children has a lot of like out of school class, like they went to tutorials to get trained some early skills, and especially in Singapore, some children, the parents also at home, they will get a lot of training from the parents, like to count the number from very young age. So I think probably the children in Singapore, they have this stronger skill in symbolic and also non-symbolic.
But do you think they're doing something different in the non-symbolic than kids in Canada and Poland and Chile, for example? Are they using different skills?
But I think the non-symbolic skill, from my perspective, because I think the non-symbolic is kind of because we have the ANS, the optimal number system. I think that is kind of very natural skill for everyone, but I'm not sure how the difference why this data from Singapore, why the two types of knowledge can predict, because we didn't control the other factors. We only consider the age and the gender.
I think we have. I wonder if Daniel has a comment about this, but this particular version of a non-symbolic comparison task is not really very much about the ANS, I don't think. Of course, we don't know that one way or the other, but children can count and they can subbutize, and a lot of the times that will tell them which is more. It may not work on every trial, but it'll work on some. And I think it would be very surprising if they weren't bringing some of those skills in to doing the non-symbolic version of this task. I mean, you can see this even with adults. If you separate out if you use a true non-ANS task, which means no small numbers, nothing less than 6 or 9 or something, the correlation with arithmetic outcomes is lower than if you use an ANS task that has small quantities in it. So I would be surprised if the children, there could be lots of individual differences in exactly what they're doing, but some of the comparisons they can certainly do by subbutizing or small quick counting and so on. So that's kind of what I was wondering, like, is it the case that the kids in Singapore have strong skills, both from that perspective, good counting skills, good subbutizing, good mapping the subbutizing skills onto the comparison task, and maybe that's something that they're getting a lot of, that's increasing their skill level overall.
Yeah, I think we can continue this kind of study in Singapore because because they study from me. Actually, it's very, very preliminary, as like Krzysztof probably. It's very preliminary. We use a screener and we didn't control a lot of factors. And also I think when we go to the schools and we recruited the children, and some children they have low like counting skills. Like at the first page of the screener we have some trials. So some children actually on the trials they don't know the 1, 2, 3 and 4. They may say 1, 2, 3 and 9. So we actually on the practice trial station we my RA actually was teaching them about the order and and which number is bigger and which number is smaller. So I think probably some other factors can be considered in the future study in Singapore.
I mean, there are some data from Patra and Hamann. We also have some data that counting procedure knowers are better in the non-symbolic task than non-knowers. This can, of course, have multiple reasons. They are better in general and doing many tasks, but it could also meaning that at least in some trials, they use counting procedures to be better.
Darren made a comment. Darren, you should say it out loud. No.
Okay. Okay.
There
So from my experience as a primary school teacher back in Singapore, my guess is that preschoolers and lower elementary levels, they do quite a bit of informal assessments where students are asked to use concrete objects and pictorial representations to as a form of assessment of their learning. So I think that may explain why there is some predictive value of the non-symbolic comparison. So yeah, we don't just assess like written performance, but also more hands-on, concrete kind of performance of what they've learned.
Are there any other questions or comments? We're slightly afternoon now. All right, well, I'd like to thank our speakers very much for a great symposium. I especially liked how you introduced all 4 talks ahead of time. It was really good for keeping to time. So thanks very much, and we hope to see you again next week.
Thanks, everybody.
Thanks, bye-bye.
Reminder, next week is posters, so it's going to be mostly on Twitter and also on the lightning talks are going to be on Zoom.
Thanks so much for organizing this, everyone. Bye.
Thanks. Bye-bye.